Welcome economic students to this online edition of Microeconomics. In this particular online video lecture, we are going to be reviewing some of the important ideas associated with pure competition as a market model. Remember, there's two types of market models. We have perfect competition and imperfect competition. Obviously, pure competition is the only market model associated with perfect competition, and it is vitally important to understand the principles of pure competition because we're going to employ these principles when we look at or evaluate the imperfect models of competition and actually compare things like efficiency to the paradigm, to the model of pure competition. So what are the characteristics of a purely competitive market? The first one is quite obvious, that there's a very large number of producers. All right, so much so that if one firm were to leave the industry, no one would notice. And matter of fact, it's so many producers that the sellers in the market probably don't even know the names of their competitors. All right. Now, what are they producing? Well, there's a very large number of sellers of producers, and they're selling what's called a standardized product, a homogeneous product. The best example of this is something like agriculture, something like wheat or corn or cotton or rice. Right, if you think about that particular product, it's impossible for one producer to differentiate their product based on quality or some type of traits of the product, because virtually every bushel of wheat looks the same, and every ear of corn is basically the same. Now, of course, we're assuming that we're talking about the same grade of agricultural product. Right? Lumber would be another good example of this. An oak tree is an oak tree is an oak tree. Now, again, assuming that they're of equal quality. So a very large number of producers producing a standardized product, and they are what are called price takers. Right? So the purely competitive firm, the single firm among the many, has absolutely positively no pricing power. And we're going to go over this particular trait of the purely competitive firm in much detail. This is an important idea to understand for introductory economic students. The idea that a purely competitive firm can sell as much as they want at the market price or as little as they want at the market price, but they have absolutely no control, zero control over the price in the market. They are price takers. All right. Now, another important idea associated with purely competitive market models is the idea of free entry and exit into the industry. So firms can leave as they please, and they can also enter if they please. So if there's short-run profits to be had, firms may enter the industry, and if there's losses remain for several quarters or even years or so, firms will leave the industry. So no what we call barriers to entry. There's nothing preventing firms from entering or exiting this industry. All right, so from the standpoint of a single firm, that is to say, how does one firm experience demand if we are talking about a purely competitive market with a very large number of sellers selling a standardized product with free entry and exit into the market? From the standpoint of this single firm, demand is perfectly elastic, and we're going to look at this graphically on the next slide. But if you remember, perfectly elastic meaning just the smallest change in price will completely change the quantity demanded. Now, in a purely competitive situation, because demand is perfectly elastic, average revenue equals marginal revenue. All right, average revenue equals marginal revenue. We'll talk about total revenue in a moment, but average revenue equals marginal revenue, and average revenue equals marginal revenue at the price in the market. So let's look at this idea of average revenue, marginal revenue, in price more closely on the next slide. All right, so up top, what does it say? Say, okay, the market versus one single firm and how they experience demand. So on the left-hand side, we have the wheat market. So there's many producers. So if you can see the green upward sloping supply curve, that is all the wheat farmers in the United States. And obviously there's thousands of producers of wheat each year. So many farmers. If you think about the Midwest, the breadbasket of the United States, there's hundreds, if not thousands, of wheat farmers, right? And if you think about market demand, well, obviously, people buy wheat directly and indirectly. We all eat bread, and we eat a whole bunch of other food items that contain wheat. So there's literally thousands of buyers as well. So how is the equilibrium of equilibrium quantity and equilibrium price of wheat determined? Well, it's determined by the interaction of buyers and sellers. So stuff we studied already when we examined markets and supply and demand. So obviously, buyers are trying to maximize utility. Right? Producers, sellers here are trying to maximize profit. As if led by the invisible hand, we come to equilibrium, the rationing function of prices. And this occurs at a market price of $4 per bushel. Right? $4 per bushel. So that's the market price based on the hundreds or thousands of farmers, the producers of wheat, and the thousands of buyers. Right? It's the interaction of those market participants that determines the market price of $4 per bushel. Well, what about the single farmer, and how does this relate to the idea that for the single producer in a purely competitive situation, demand is perfectly elastic? Well, if you're one farmer among the many, the way you experience demand is you can sell as much wheat or as little wheat at $4 per bushel as you choose, right? However, you can see because the individual farmer experiences demand as perfectly elastic, has absolutely positively no pricing power. If this farmer were to raise its price even by a quarter, 25 cents a bushel, no one would buy from this farmer. Why? Because there's so many producers producing a homogeneous or a standardized product that no one would buy wheat from a producer, a seller, a farmer trying to sell it at above the equilibrium price. The buyers can buy it at the equilibrium price. There's no need to spend anything more than the equilibrium price. Interestingly enough, the firm would also be doing itself a disservice by lowering price, because the producer here can sell as much as they want or as little as they want at the market price. So again, the market price is determined by the interaction of thousands of producers and thousands of buyers. The buyers and sellers, supply and demand, and that came to say $4 per bushel for this month or this week. So from the standpoint of the single producer, one firm, one farmer among the many, demand is perfectly elastic at the market price. So for our situation, $4 is the price in this particular market, right? And from the single producer standpoint, it's the marginal revenue as well. Marginal revenue means how much the firm will receive in additional revenue from selling the next item. Right? Anything marginal thinking is change, so change in total revenue associated with producing one more unit of output. So each time this firm produces and sells, they'll sell it to market price. So the price will equal the marginal revenue. So P equals MR. And because, if you take anything and you divide it by the number of units sold, you're going to get its average. Well, in this particular situation, in a purely competitive situation, price will equal marginal revenue. It will also equal average revenue. All right, let's look at this in a little more detail on the next slide about marginal revenue, average revenue, and then we're also going to talk about total revenue. So on the left-hand side here, you have a firm's demand schedule. Right? This is one producer in a purely competitive situation. You can see that the price is 131. Whether they sell 1 unit of output or 10 units of output, they will do so at the market price. So we have that numerically on the left-hand side where it says firm's demand schedule and it says average revenue. So price in the market is 131. Now remember, how was that price determined? That was determined by the thousands of buyers and the hundreds or thousands of sellers interacting to bring the market to equilibrium at $131 per unit. So this firm experiences demand as perfectly elastic at $131, can sell as much or as little as they want at the market price, right? So from this standpoint of the single firm, the demand equals marginal revenue, also equals the price in the market, right? And it also equals the average revenue. What about total revenue? Well, we covered total revenue before. It's simple. It's just, price you're selling something times quantity you sell it, right? So P times R. So each time the firm produces another unit, they will do so at $131 $31. So you notice that total revenue increases by $131 each time this firm produces and sells one more unit of output. And obviously the marginal revenue associated with each of these is $131. All right, let's analyze some short-run production decisions of a single firm, one producer in a purely competitive industry. All right, we're going to use what's called the MR equals MC approach to profit maximization in the short run. So MR is marginal revenue. Again, marginal revenue is the change in total revenue associated with producing and selling one more unit of output. And we know that in a purely competitive situation, the firm will sell each unit at the market price. So the marginal revenue of the first, second, third, millionth unit is the price in the market. So price equals MR, or marginal revenue equals price. So it doesn't matter which unit we're talking about, it will always be the price in the market for marginal revenue in a purely competitive situation. And marginal cost, we covered the idea of cost in a previous chapter. Marginal cost is the change in cost associated with producing the next unit of output. So the firm is going to equate the marginal revenue, which is the change in total revenue, the additional revenue they receive from selling one more unit of output, to the marginal cost of producing that next unit of output in order to maximize profit or minimize loss in the short run. So remember, short run is the period of time when at least one resource is fixed. Typically we talk about the size of the plant or the firm, the factory, as being fixed. So you can think of the situation where we say, okay, for the next 3 years, the size of this firm is not getting any larger because its plant size, its factory, is fixed. And remember, short run versus long run for an economist, it's not a specific time period like an accountant. It's the time when at least one resource, typically capital, typically the plant, is fixed. Okay, so some questions. Number one, should product be produced? In other words, should the firm produce in the short run? And the answer to that question is maybe, right? Maybe. Well, that doesn't help us. Maybe. Well, the firm should produce if it's going to make a profit, or the loss in the short run will be less than its fixed costs. Okay? So the first question the firm must produce when the firm must answer when they employ this marginal revenue, marginal cost approach to profit maximization or loss minimization in the short run is, should the firm produce? And the firm should produce if it's going to make a profit, so duh, of course, or if in the short run the firm's loss will be less than its fixed cost. So real quick review, and I'm going to go over this several times because it's important. Remember, fixed costs are the costs that do not change with the firm's level of output of production and are unavoidable. Right? So in the short run, a firm should produce if it's going to make a profit or at least cover some of its fixed costs. So the next question is, okay, well, if so, what amount? That's where we bring in MR equals MC. We're gonna see this numerically and graphically, that the firm should produce the profit maximizing or loss minimizing amount in the short run where marginal revenue is greater than or equal to marginal cost. So the additional revenue from producing the next unit of output is just a bit greater than or equal to the cost of producing that next item, that next unit of output. All right, and then after we have, assume we've said, even if we assume we've answered these two questions, should the firm produce? If so, what amount? Finally, we will answer this last question, which is obviously quite important. What economic profit or loss will be realized from their short-run production decisions? So a firm operating in an industry which is purely competitive is going to use the MR equals MC rule to either maximize profit or minimize loss in the short run. So let's review some of the important relationships between the MR equals MC rule and the cost concepts we covered in a previous chapter. Now remember, price equals marginal revenue, because each time the firm sells an additional unit of output, they will do so at the market price. So they will receive the same amount of additional income by producing and selling one more unit of output, and that will be the price determined by the thousands of buyers and sellers in the market. So price equals marginal revenue. So the first question to be answered, if producing is preferable to shutting down. So in other words, if it is worth the firm's effort to go ahead and produce. Otherwise, in other words, they will make a profit in the short run, or they're going to operate at a loss less than their fixed cost. What units, what quantity of output, what level of output should the firm produce? The firm can determine Q star, which is quantity of output, which either maximizes profit or minimizes loss. The firm determines what level of units, what number of units to produce in the short run, by equating marginal revenue to marginal cost. So the firm should produce the quantity where MR equals MC. Marginal revenue equals marginal cost. So the additional revenue from producing the next unit of output is just about greater than or equal to the marginal cost of producing the next unit of output. Again, if producing is preferable to shutting down, and we equate the price in the market, again, which is marginal revenue, to the average total cost curve, it will determine for the firm in the short run whether we are operating at a short run profit or operating at a loss less than our fixed cost. So the relationship between marginal revenue and average total cost is important because it determines short run profitability for the firm. Now, the all-important question, in the short run, should the firm produce? We already know that if the firm should produce, they should produce the profit maximizing or loss minimizing level of output where MR equals MC. Wonderful. How do we know if the firm should produce? This last idea is vitally important. In the short run, the firm should produce when we equate marginal revenue to the average variable cost at Q star, at either profit maximizing or loss minimizing level of output. So the firm should produce in the short run if the price in the market is greater than or equal to the average variable cost at MR equals MC. These ideas will become much more clear as we go through some solid examples graphically and numerically. Okay, now let's employ some of the ideas we learned previously regarding cost concepts and price for a single firm operating in a purely competitive market. Column 1 here is simple. Total number of units produced. Let's assume this is per month, right? So we're going to be looking at production decisions for the short run. This is per month for this particular firm. Column 2 is simply average fixed cost. Now remember, a firm should produce in the short run if it's going to make a profit or its loss will be less than its fixed cost. So obviously, it's vitally important for you to understand how do we get the fixed cost. So if you were given this data, how would you determine fixed cost for the firm for 1 month, for this time period? Well, average fixed cost is your total fixed cost divided by quantity of output. Therefore, at one level of output, right, average fixed cost equals your total fixed cost. So for this firm, their total fixed cost per month is $100. Okay, so that's very important. So obviously, this firm will produce if they're making a profit or their loss is less than $100. Right, that's an important idea to grasp right off the get-go there as far as your total fixed cost for the short run. Now remember, fixed costs are unavoidable and do not change with the level of output. Then we simply look at our average variable cost and our average total cost data, right? Both of these curves would reflect the law of diminishing returns as costs start at some relatively high level, begin to drop, and then beyond some point start to rise again. So those U-shaped curves reflect the law of diminishing returns that all firms face in the short run because the size of the factory is fixed. Marginal cost, extremely important idea here again. The cost associated with producing the next unit of output. Now remember, we're going to equate marginal cost with marginal revenue to determine in the short run what is the quantity of output which will either maximize profit or minimize loss for this firm. So assuming producing is preferable to shutting down, we will always determine what number of units, what quantity, also called Q star, of units to produce in the short run by equating marginal revenue and marginal cost. Now, marginal revenue, remember, this firm is a price taker. They can sell as much at the market price or as little at the market price as they desire, but they have no control over price. They have no pricing power. Right? So they're price takers. They're price takers at the market price. So you might think of this as the market for lumber, right? You can say this is the market for cedar wood. It's an expensive cedar wood, and this is, say, per quarter ton. So for a quarter ton of cedar wood, it's $131. That $131 was determined by the thousands of buyers and sellers in the market, and now we're just one firm. We're price takers at the market price. So demand is perfectly elastic for this firm at $131 per quarter pound of board foot, right? Okay, so knowing that, what level of output should the firm produce if this is the cost data it faces versus the marginal revenue, right? So we simply look at this data and say, okay, where does marginal revenue equal marginal cost? Well, we see that marginal revenue exceeds marginal cost all the way up to the 9th unit of output, right? Because at 9 units of output, marginal revenue is $131, but the marginal cost of producing that next unit of output, that 9th unit of output, is $130, right? But what happens at the 10th unit of output? Well, at that point, marginal cost actually exceeds marginal revenue. So this firm would never want to produce that 10th unit of output because the cost of producing that next unit of output exceeds the revenue they would receive from producing and selling that next unit of output. So for this one, it's quite simple that MR equals MC at 9 units of output. So if this firm should produce, they should produce 9. Okay, so will this firm make a profit? Well, yeah, in the short run, right, this firm will make a profit of $299 as highlighted here in the yellow. Now, how did we get that? Well, there's actually two ways to determine that the firm's profit maximization number or loss number in the short run here, right? So the firm's going to sell 9 units of output because that's using the MR equals MC rule to determine Q star, right? Profit maximizing or loss minimizing level of output in the short run. We easily decipher to determine that this firm should produce at 9 where MR equals MC. So how do we determine profit for this firm in the short run then? Well, there's two ways to do this. You can take 9 times 131 for total revenue, right? Because 9 units sold times price of each unit gives you total revenue, right? That would give you your total, and you could subtract that from total cost. So how would you get total cost? You could take 9 times column number 4 at 9 units of output is 97.98, right? So average total cost, which is per unit cost there, right? So you could take those two numbers, and then if you subtracted your total revenue from your total cost, you would come up with $299. There's another way to do this, and it should be intuitive to most of you if you think about it. You can simply take your marginal revenue, which is $131, right? And you could subtract your average total cost at 9 units of output of 97.78, and that would give you your per unit profit, right? How much were you making on each one you sold? And you simply times that by 9, and that would also give you $299. So, quick review here. This firm should produce because they're going to make a profit, and the profit maximizing level of output is 9 units, not Q star is 9, where MR equals MC. Let's look at this graphically, and then we will drive home the ideas of the relationship between marginal revenue, marginal cost, average variable cost, and average total cost. Okay, so here's the same idea graphically. Right? The firm is a price taker at $131 per unit. So marginal revenue equals price at $131. So for this firm, demand is perfectly elastic at the market price. Sell as much as they want at the market price or as little as they want at the market price, but have absolutely no control over price. When we look at the relationship between MR equals MC, we know that if this firm should produce, based on just these two graphs, we say if the firm should produce, they should produce 9 units of output. Why? Well, the MR equals MC rule, that tells us that the marginal revenue of producing the next unit of output is greater than or equal to the marginal cost of producing that next unit of output. Now, if you were just given this data, now I know we just looked at it numerically on a previous slide, but if you were just given this data, you could not yet determine whether or not this firm should produce. You would need more information graphically to determine if this firm should produce. Well, here's more information. The average variable cost curve. So ABC, average variable cost. We notice that at 9 units of output, price, right, 131, exceeds average variable cost. So if price is greater than average variable cost at Q star, right, if price is greater than average variable cost at 9 units of output, this firm should produce. Right, this firm should produce. We can also determine based on the relationship between price, 131, right, and average total cost if this firm will make a short-run profit or operate with a short-run loss. And the answer here is obviously they're going to make a short-run profit. So you can see this with the nice highlighted rectangle, right? If we say, okay, the difference between the price the firm receives from selling each unit, which is $131, versus the average total cost at that level of production, which is $97.98. The PowerPoint slides nicely highlight that for you. That entire geographic region, obviously where it says economic profit, right, that would come up to $299. Now remember when you were in something like 6th or 7th grade math class and you said, well, I never have to learn anything about area of a rectangle. Now you actually see the value in this, right? If you take the difference between 131 minus 78, right, that gives you the height of that lime green economic profit rectangle, right? And you would times that by 9, right? So that's the length times the width, I should say. Like length times width is area, and obviously area here is profit, right? Okay, now that we understand the idea or the relationship between price in the market, marginal cost, average variable cost, and average total cost, what happens when something changes in this market? This is going to be what we call the loss minimizing case. The loss minimizing case. Now remember, still a short run decision here. We're saying, this is for the firm's decision for this particular month. Price has fallen to $81 per unit. Now remember, price is determined by the buyers and sellers, like thousands of buyers, thousands of sellers. So we have no control over price as one single producer in a purely competitive situation. We can sell as much or as little to market price as we desire, but we're price takers, and at this point we're price takers at $81 per unit. First, you notice that the marginal revenue curve, or the price line as we call it, right, because P equals MR if we're analyzing a purely competitive situation for one single firm, has dropped all the way down to $81 because price is now $81. The next question is, given a market price of $81, if we should produce, what's the profit maximizing or loss minimizing level of output? Well, MR still equals MC will still tell us if producing is preferable to shutting down in the short run, this firm should produce 6 units of output, where MR equals MC. The marginal revenue of producing the next unit of output is greater than or equal to the marginal cost of producing that next unit of output. All right, now again, should the firm produce? Well, maybe, right? Maybe we would need to know a little bit more, and we do when we look at the average variable cost curve. Well, good. For this firm, things aren't too bleak yet because price still exceeds average variable cost. So again, if you look at that relationship between price, right, the marginal revenue curve, and the average variable cost curve at 6 units of output, as long as price is greater than average variable cost, where MR equals MC, where marginal revenue equals marginal cost, producing is preferable to shutting down, right? But the bad news here is that price has fallen below average total cost. The price has fallen below average total cost. All right, so let's look at the information on the PowerPoint slide and talk about the loss minimizing case, right? This firm can sell as much as they want or as little as they want at $81 per unit. Based on their cost structure for this month, right? If producing is preferable to shutting down, this firm should produce 6 units of output, where MR, marginal revenue, $81, is greater than or equal to marginal cost. So we know that if they should produce 6 units of output. We also know that they should produce, indeed, because at $81, price is still greater than average variable cost, the brownish curve. Unfortunately, because price has fallen below average total cost, because $81 is less than the average total cost of $91.67, right? This firm is going to lose, what's that, you're selling them for $81, your average total cost is $91.67, so you're losing $10.67 for each one you sell. Now students might say, well, why in the world would you operate at a loss in the short run? Why not just close down? Well, remember, our fixed cost, right? If we do nothing, if we sat on our laurels and did nothing, didn't operate the firm, we would lose 100, right? In this case, we lose 6 times, they say 11, just round it up a bit, right? We lose about $66, right? So, well, that's not good. Losing money is not good, but guess what? Losing 66 is much better than losing 100. Now, of course, this would have a lot more real-life application, or these results would be amplified if we were talking about thousands or hundreds of thousands of dollars. So imagine if this firm had a decision of, okay, we can either lose $100,000 this month, or we can lose 66 and thousand and change. Obviously, we would much rather lose 66 and change. That's why, in the short run, producing is preferable to shutting down if we're going to make a profit, or we're at least going to cover some of our fixed cost, right? As long as the loss is less than the fixed cost, it makes sense for this firm to go ahead and produce. Okay, what about a situation where in the short run, the firm should actually decide to shut down, right? Well, again, the market determines the price. The interactions of the thousands or hundreds of buyers with the interaction of all the sellers determines the price. And now price has fallen significantly. So if we were talking about the market for cedar wood, right, why did the price fall from $131 to $81 to $71? Well, it could be quite simple, right? The recession of 2007 through 2009, the demand for lumber has fallen quite significantly. Construction is down all across America. So it's not unreasonable to think that prices of raw materials could be cut by 30, 40, 50%. So there's significant decrease in demand because buyers' income or number of buyers has declined, so therefore the demand curve has shifted left. So now the new price in the market is $71. So again, take it or leave it. For us, we're price takers. We're one firm among the many. Right? In a purely competitive market, we have no pricing power. So let's see what happens at $71 per unit. So here's our new price line, our new marginal revenue curve. So for one firm, our demand curve is perfectly elastic at $71. We can sell as much as we want or as little as we want at $71. So should we produce in the short run? Well, MR equals MC at 5 units of output. So if producing was preferable to shutting down, we would produce 5 units of output, right? Unfortunately, look what's happened. The price in the market has fallen below average variable cost. The price in the market has fallen below average variable cost at Q star, right? So we said, okay, if producing was preferable to shutting down, we should produce 5. Why? Because that's where MR equals MC. That's where the marginal revenue of the next unit is greater than or equal to the marginal cost of the next unit. Right? Unfortunately, we should not produce though, because we're not going to have a situation where we make a profit. As a matter of fact, we're not not going to make a profit, but our loss would be greater than our fixed cost. Right? Our loss would be greater than our fixed cost. That's why we would shut down. Right? So what will be our loss then if we shut down? Here's a mistake a lot of introductory students make. Right? Should the firm produce? No. Why not? Well, because at this situation, shutting down is preferable to producing because if we went ahead and produced, our loss would be greater than our fixed cost. So, what is our loss then? 0? No. For this firm, the loss will be its fixed cost, right? The loss will be $100 per month. The reason why this firm should shut down is because if the firm went to the bother of trying to produce and sell at $71 per unit, the loss would be something greater than $100. So why would we operate if we could simply lose $100? Right? So in this case, shutting down is preferable to producing because yes, we're going to have a loss. Yes, our loss will be equal to our fixed cost because fixed costs are unavoidable and do not change with the level of output, but the price in the market has fallen so low that in the short run, producing would actually create a loss of something more than $100. Okay, this is the end of the chapter problem. I'm going to go over in detail. This is simply the cost data for the problem. All right, same ideas we've just been going over. All right, left-hand column total product, average fixed cost, average variable cost, average total cost, marginal cost. Now, I took the bother of putting in parentheses the marginal cost of the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th unit, as you can see all the way on the right, only because it's difficult to sort of line these up with your eyes. So, the marginal cost of producing the first unit is 45. The marginal cost of producing the fifth unit is 35. Marginal cost of producing the eighth unit is 55. All right, because this way you can clearly see when we talk about short-run decisions, marginal cost versus marginal revenue. All right. Now, let's see who's been paying attention. Based on the data in front of you, what is this firm's fixed cost per month? So in other words, what is this firm's unavoidable cost that will not change with the level of output? What are its fixed costs? Well, you should have determined that fixed cost for this firm are $60 per month. All right. Again, how did we get that? Well, average fixed cost at 1 unit of output is 60. What's average fixed cost? It's total fixed cost divided by quantity of output. All right, so therefore, total fixed cost of 60 divided by 1 is still 60. So for this firm, producing will be preferable to shutting down if they're making a profit or their loss is something less than 60. So the question starts off by asking, if the price in the market is $56, should the firm produce? And if so, what would be the profit maximizing or loss minimizing level of output, and determine the firm's profit maximization, the profit or loss in the short run, right? So price is $56, right? So don't look at the answers yet. Obviously, they're right there in front of you, so you can just look them up. But the first thing you do is say, okay, if the firm should produce, right? If the firm should produce, the MR equals MC rule. What level of production should the firm produce? So if producing is preferable to shutting down, this firm should produce at 8. Right? See in the red there, 8 level of output, because 56 is greater than or equal to 55. Marginal revenue, remember, the market price is the market price. We're price takers at the market price. So for our firm in a purely competitive market, right, we can sell as much or as little at $56 as we wish. Price equals marginal revenue, right? So each additional one we produce and sell, we sell at the market price. Right? We have no control over price. Therefore, price is greater than or equal to marginal cost. Marginal revenue is greater than or equal to marginal cost at 8 units of output. So MR equals MC at 8. So if the firm should produce, this firm should produce 8 units of output. Because look what happens at 9 units of output. Right? At that point, marginal cost is well above marginal revenue. We would never choose 9 units of output if the price in the market is 56. So the next question is producing preferable to shutting down? Well, if you look at 8, right, in the average variable cost column, we say, okay, as long as price is greater than average variable cost, right, for 8 units, then producing is preferable to shutting down. All right, let me say that one more time. All right, we look at 8 in the average variable cost column, and as long as price 56 is greater than average variable cost at 8 units of output, then we should produce. So for this particular case, look, price is 56, right? That's our marginal revenue. It's greater than $40.63. So I actually put that in green to say, hey, go ahead and produce. All right, as long as price, right, marginal revenue is greater than average variable cost at Q star, it makes sense to produce. So the final question of the piece of this puzzle is, will this firm make a short-run profit or operate at a loss? And if so, how much is it? Well, this is quite simple as well, right? In column, in the first, second, third, fourth column there, your average total cost column. Average total cost at 8 units of output is $48.13. So what we're saying there is that this firm will produce and sell each unit at the market price. So marginal revenue equals price at $56. All right, the average total cost at 8 units of output is $48. So therefore, yes, this firm should produce because price is greater than average variable cost at Q star at 8 units of output. All right, will they make a profit? Yes, because we take the we take the price in the market, which is 56, minus your average total cost, and therefore the per unit profit is $7.87. All right, so each of the 8 we produce, we make $7.87. So if we simply take 8 times $7.87, that will come out to your total profit of $62.96. All right, what happens? What happens if price falls in the market? It says, okay, now it says, oh, what happens if market price is $41? All right, same question. Should we produce? And if so, what units should we produce? And will we make a profit or loss, right? So, first, $41 is the price in the market. We're price takers. This firm, therefore, should produce 6 units of output if producing is preferable to shutting down. All right, now how did I come up with that number? Now for you people, obviously I made it easy. And you look at MR equals MC, right? The MR equals MC rule, right? We always determine the profit maximizing or loss minimizing quantity of output by equating marginal revenue with marginal cost. And for this firm, marginal revenue is greater than or equal to marginal cost at 6 units of output, right? That's why I highlighted that in red. So this firm, if they should produce 6 units. Well, what's the average variable cost at 6? Average variable cost is $37.50. All right, so a price of $41 is greater than average variable cost of $37.50. So again, I put this in green. This firm should produce because price is greater than average variable cost at Q star at 6 units of output. All right, now here's the bad news, right? Although price is greater than average variable cost, look at the relationship between price and average total cost. All right, we're producing and selling each unit at $41 per unit. All right, the price equals marginal revenue. We're price takers. We have to sell at that price. We have no control over price. Right? Unfortunately, average total cost at 6 units of output is $47.50. That means we will lose $6.50 for each one we produce and sell. All right? How did I get that? Simply price $41 minus average total cost $47.50 at 6 units of output means there will be a per unit loss of $6.50. Now, we take $6.50 and that comes out, then we times that by 6. That comes out to a total loss of $39. Not good, right? Not good. We're losing money, right? We don't want to be losing money. However, remember, as long as our loss is less than our fixed cost, producing is preferable to shutting down. Right? And our total fixed cost for this firm was $60. We reviewed that in an earlier slide. You can also see it here that, fixed cost at average fixed cost at 1 unit of output is 60. Therefore, total fixed cost is 60. So as long as we're making a profit or our loss is something other than or lower than 60, as long as our loss is lower than 60, producing is preferable to shutting down. Right? Finally, what happens when price falls all the way down to $32? Well, this is going to be that shutdown case, right? We say, okay, we should produce, if we were going to produce, we should produce 4 units of output where MR equals MC, right? But look at what happens. As soon as we say, okay, what about the relationship between price and average variable cost at 4, at Q star? Price is 32, average variable cost $37.50. Because price has fallen below average variable cost, this firm should shut down. Why? because if the firm went ahead and produced, its loss would be greater than its fixed cost. How do we know this? How can we prove this? Well, let's say we did go ahead and produce, and this wouldn't be good because look at what happened. All right, we'd be selling each unit for 32, but our average total cost at 4 units of output is 52.50. So we would be losing, right? For each one, we'd be losing $20.50. All right, 4 times 20.50 comes out to a loss of 82. So in this case, it's best for the firm to shut down. Now, remember, when the firm shuts down, they will not lose zero by doing nothing. They will lose fixed cost. So this firm's loss in the short run will be its fixed cost, $60. All right, quick review, because $32, which is the price in the market, all right, has fallen below average variable cost at 4 units of output. In this case, shutting down is the best decision for the firm.